February, March 2019, paper 3, variant 2. Question 1. We have some different masses of the same material. Identify one quantity that is the same for all of the masses. What's one quantity that should be the same for all of them?
Density.
Density. It has to be the density. The largest mass is 2.5 kilograms. State the number of grams.
2500.
2500.
2500. From kilograms to grams, we just multiply by 1000, 2500 grams. The three largest masses are 2.5, 1, and 0.5. Calculate the combined weight of them.
نعملهم بلس تايمز 9.8 عشان الجرافيتي
2.5 plus 1 plus 0.5
يطلع
total
4
mass of 4 kilograms. How can I find the weight? Weight equals
تايمز 9.8
weight equals
weight equals mass
mg.
times gravity
4 times 9.8, which is
39.2
39.2. And what's the unit?
Newton and
Okay, piece of cake. I have some students going on a bus. Now I'll need to draw the speed time graph. Let's draw the speed time graph. The bus accelerates from rest at a constant rate for 10 seconds. It reaches a maximum speed of 10 meters per second. Initially, the bus was at rest. It accelerates for how many? For 10 seconds. Reaches a maximum speed of 10 meters per second. So after 10 seconds, it reached a maximum speed of 10 meters per second. So I have a point. And then what should I do? I should draw a straight line. That's it. Straight line using your ruler, definitely. Then the bus maintains a constant speed of 10 meters per second for 60 seconds. Constant speed, 10 meters per second for 60 seconds. So I will draw a horizontal line until which point? Until it reaches which point? I will draw a horizontal line. Till the end, for example?
till 60
60, till 60.
70 seconds.
70, yes. Until 70 يا شباب. Why? Because he said for 60 seconds. Okay. Initially, he was at 10. He reached the speed of 10 meters per second after 10 seconds, and then he continues on the speed for 60 seconds. So I will add 60 plus 10, it will be 70. So 70 هنا, I'll draw a horizontal line until it reaches 70. Okay? Then the bus decelerates at a constant rate for 15 seconds until it stops. 15 seconds until it stops. Deceleration, okay. At which point should it reach on the x-axis?
85 seconds.
85, bro. Yes, 70 plus 15 would be 85. So at this point, I will draw a straight line using the ruler. Okay, definitely, Shweb. You have to draw all of this using a ruler until I reach 85. That's it. Quite easy. Five marks. That's a lot. That is a lot for one question. But it's quite easy, I guess. On another part of the journey, the average speed of the bus is 7.5 meters per second. Calculate the distance traveled in 150 seconds. How can I find the distance?
Area under the graph.
Speed by time.
Speed times time, not area under the graph. Okay. Why is it not area under the graph? Because he said the average speed is 7.5 meters per second. He's not talking about the same graph. I'm not talking about the Same graph. Calculate the distance traveled in 150 seconds. When I say average speed, so in this case, you can use distance equals speed times time. Distance equals speed times time, which is 7.5 times 150, which would give me a total distance of, what's the total distance?
1,125.
1,125. 1,125 meters. Okay. State the name of the force acting vertically downwards. Wait.
Wait.
It is wait.
Is it
Yes.
gravity?
Wait. Usually gravity is wrong. Usually gravity is wrong. So we'd better write down wait. The vertical force that acts upwards is 4 newtons. State the value of the vertical force downwards. While it is at rest, while it's stationary. What's the vertical downward
4
force?
newtons.
4 newtons. Can I find the resultant force and the direction for this point? Resultant force is
4.8 upwards.
4.8 upwards. 7.6 minus 2.8 would give me a total resultant force of 4.8, and the direction is upwards. Hello. State the principle of conservation of energy. Principle of conservation of energy. What was it?
Energy neither created nor destroyed.
Okay. Energy is neither created nor destroyed. If you had 2 marks, you could have continued and said it only changes from one form to another. But for this question, you can just write down energy is neither created nor destroyed. Eventually, the load stops moving up and down. Describe and explain why the load stops moving. Use your ideas about conservation of energy. Kept on moving. When you pulled it down, it kept on moving up and down. And then after a while, it stopped. Why does it stop?
Due to it losing energy to its surroundings.
Energy is lost to the surroundings. What type of energy was lost to the surroundings?
Can I say by fraction?
Thermal, okay. So the kinetic energy in the spring was lost as thermal energy to the surroundings. That's correct.
بس انا ممكن اقول fraction ولا fraction غلط؟ عشان هما بيلمسوا بعض يعني لما بيجي.
Um, due to friction يعني you mean?
Yes.
Okay. But again, lost to the surroundings due to friction also.
Okay.
Kinetic energy in the spring was lost to the surroundings as thermal energy, as heat energy. Okay. يلا حلو. The truck is stationary. Tick the box next to each correct quantity. I need to determine the work done. I need to determine the
Distance
work
and force.
done. Distance and force. Draw the ring around the unit. for the work
Joule.
done. Joules. Identify the quantities to determine the power of the truck. Power. How can I find the power?
Energy transfer.
Yes, energy and time. Correct. Bravo. Time and energy. Truck is in equilibrium. Calculate the load. How can I find the load?
هو قال equilibrium يبقى دي هتساوي زيرو
اه لسه
يعني
اقول.
لا 1.5 equal
تمام clockwise
30,000
equal
newtons
anti-clockwise.
I can
طب استنى wait. Whenever I say equilibrium يا شباب احنا we have to write down clockwise moment equals anti-clockwise moment. Okay, you have to write it down. Clockwise moment equals anti-clockwise moment. The 30,000 newtons, is this exerting a clockwise moment or an anti-clockwise moment?
Anti-clockwise.
Anti-clockwise moment. And the load, is it exerting a clockwise or anti-clockwise? It's quite obvious. Clockwise. Okay. Clockwise moment is force times perpendicular distance. So load, I'll name it F, for example. Force times perpendicular distance, which is 1. F times 1 is equal to the anti-clockwise moment, which is equal to force times perpendicular distance, 30,000 times 1.5. So F times 1, which is F, equals 45,000 newtons. Okay, 45,000. Definitely, if the distance was anything other than 1, for example, if the distance was 3, okay, what would I have done? I would have divided the 45,000 divided by 3. Okay, but since the distance is 1, so you can divide by 1, it would remain the same number. On figure 4.3, draw a cross to indicate the center of mass of the pile of bricks. Center of mass, quite easy. It's in the center of this rectangle. You'll find the center. It's somewhere around here. Easy. Why does he tilt it backwards? Why does he tilt this pile of bricks backwards?
Lowers the
does
center of mass.
what?
Lowers the center of mass.
Lowers the center of mass. Okay. What
عشان
else?
يبالانس البريك عشان تبقى more stable.
Okay, more stable, balanced. It's already balanced. Okay, but the question is, how does the stability increase?
increasing مثلا the surface area.
No. You're not
Well,
increasing the surface area. You're not
يعني by
increasing.
by bending like he almost did it يعني.
لا, the
عشان
surface area,
يخلي ال center of mass closer للpivot.
it is closer to the pivot, yes. It's not lower. Okay, someone said that the center of mass was lower. لا, it doesn't get lower in this question. It doesn't get lower. It does get closer to the pivot. What do you mean gets closer to? It's just a slight difference. It's a very slight difference, but it does get closer to the pivot. So whenever the distance decreases, whenever the distance between the center of mass and the pivot decreases, so the moment itself decreases. So it becomes more stable. Okay, whenever the distance between the center of mass and the pivot decreases, therefore the moment decreases, it becomes more stable. It's a tricky question. Again, these are the questions of March. These are the March questions. They have to be a little tricky, okay? A little out of the box. Eva, again, explain how tilting the pile, okay? How does it make it more stable? It decreases, okay? The distance between the center of mass, and the pivot. Okay. Okay, يلا. Moving on. I have a solar farm. State the energy source and the useful form of energy. What's the energy source and what is the useful form of energy for this solar farm?
Light energy to electric.
Okay. Source is the sunlight. And the useful form, how do I use it as electric energy? Okay. Solar farms have advantages and disadvantages. Two advantages of the solar farm.
renewable و non-polluted.
Okay, renewable doesn't produce carbon dioxide. Pollution. No carbon dioxide pollution. What is one disadvantage?
Not reliable.
Not
Not reliable.
reliable طبعا. Not. So just why is it useful for the panels to rotate?
عشان يعني يمشي مع السن أو يعني
صح.
كده.
عشان
track.
to absorb more sunlight to make electric energy.
To track the sun and face the sun more, whatever. Okay. أو بلاش track, to follow the sun would be better. Okay. I have a heating element inside an electric oven. Draw two arrows to show how thermal energy moves throughout the oven by convection. By
الهيتنج element هيبقى up to the left وينزل.
okay.
بعد كده الارو التاني هيبقى تحت ويرجع تاني.
The heating element, what does it do to the air? The hot air moves upwards this way, and then when it gets colder, moves back down and to the heating element again. That's the whole point of convection currents. Keeps on moving in circles. Explain how thermal energy moves throughout the oven by convection. We know how convection moves, huh? Can someone remind me? How does convection transfer heat? Any ideas?
The hot air go up and the cold air go down.
Hot air moves up and cold air
Due
moves
to hot air having less
عشان hot
density
air بيبقى فيه less
than cold air.
density.
less density. Thank you. Okay, so hot air, volume of the hot air increases. Volume of the hot air increases. Therefore, the density decreases. Therefore, it moves upwards. Huh? Hot air moves upwards. Cold air moves downwards. Cold air moves downwards. And then that's it. That's all we need to say. Use a word from the box to complete the sentence. Thermal energy travels at the speed of light by
Radiation.
definitely radiation. To be more specific, we can say by infrared radiation. The oven in a kitchen, it's fitted with a smoke detector. Suggest the best position for this smoke detector. Where should the smoke detector be inside the kitchen?
السيلينج.
Yes, on the ceiling. Correct. Draw a line from each statement to the correct term that describes it. Change in the direction of the light when entering a medium.
Refraction.
Refraction, صح. Very high frequency sounds.
ultrasound.
Ultrasound. Ultrasound. Glass prism producing a spectrum.
Dispersion.
Dispersion.
Light spreading after passing through a narrow gap.
Diffraction.
Diffraction.
Diffraction. Sound
Echo.
reflecting. Echo.
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 Complete figure 8.1 with the names of the missing types. Yeah. Higher frequency.
Radio micro.
Okay, so you start from right to left. Okay, radio, then microwaves. Okay. And then
X-ray. سوري رامي ده infrared.
infrared. Okay.
بعد كده X-ray بعد كده جاما.
Okay. And then هنا X rays and then gamma. Okay. One used for ultraviolet radiation. Tan. Okay. Tanning beds.
detecting fake banknotes.
On detecting fake banknotes. Detecting fake bank notes. I have two types of circuits. Quite easy. Well, first one is
parallel والتانية series.
okay, parallel and series. To disadvantages of the circuit in 9.2. Disadvantages of 9.2.
Doesn't have the same voltage. Can't control lamps separately.
Okay. Can't control the lamps separately. Okay. What else? Don't have the same voltage. Okay. I need the third one, which is what's the third disadvantage? If one lamp breaks, what will happen?
The others will break.
Okay. If one lamp breaks, the others will switch off or whatever. Redraw the circuit in 9.1 with switches that will turn lamps X and Y on and off independently. We just need to add switches. We'll add switches to the parallel circuit, which is quite easy. Have the power source, and then I'll add a switch to lamp X, and then another switch to lamp Y. That's it. Very simple. Yeah. Lamps can be turned on and off using different switches S1 and S2. Complete the table stating when the lamps are on or off. If S1 is at K and S2 is at Z, the lamps are off. If S1 is at K, but S2 is now moved to W, S2 is now moved to W. For example, I'll just remove S1. I'll just remove this one. What will happen? Will they be on and off? On or
On.
off? They will be on.
On.
Okay. They will be on. Again. S1 is at J, S2 is at
Off.
W.
Off.
Okay. Off. And then J and Z would be
On.
Easy. I have an iron nail, cotton thread, plastic. Which of these are conductors and which of these are insulators? Aluminum.
Conductor.
Conductor. Plastic.
Insulator.
Insulator.
Iron.
Conductor.
Conductor.
Cotton. Insulator.
Insulator.
How can the strip be given a negative charge? How can it be given a negative charge? Yell.
By getting an electron.
By gaining electrons from
Another insulator.
okay, another insulator from a cloth, for example, gaining electrons. Yeah, gaining electrons from a cloth by friction. You have to say that they will, for example, be rubbed against each other or whatever, that there is some friction. And this friction is what causes the transfer of electrons. How can I use this apparatus to demonstrate that the polythene strip has a negative charge? How can I use it to demonstrate that it has a negative charge?
نجيب
Get a
negative
cloth with a
بعدين
negative charge and they will repel each other.
Okay, يبقى approach another negatively charged rod, for example, and they should repel. Yeah, and they should repel. ماشي. Okay. Have a relay. I have a relay. Statements describe the action of the relay. They are not in the correct order. Place the statements in the correct order. One has been done for you. خلاص, he wrote down S. Part C, attract the armature. Initially, how should I switch it on? How should I switch this relay on? I can zoom out. What do you think?
T.
T. The switch is closed. When I close the switch, the current will pass. Okay, so when I close the switch, what happens when I close the switch? I just said it.
أظن
P.
تبقى R.
R
P.
or P? When you
P.
close the switch, first, what happens? The current starts to pass. The current starts to pass through the coil. Current starts to pass through the coil, P. And then, خلاص, he said that part C attracts the armature. Now, the armature will be attracted to part C. What happens? When I attract this armature, what will happen to this part?
R.
R, okay, and then Q. R and then Q. R, the armature pivots closing the contacts, and then when the contacts are closed, the secondary circuit is complete. That's it. That's it. Again, current passes. I have to close the switch first, definitely. When I close the switch, what happens? The current passes through this coil. When the current passes through this coil, it creates a magnet, north and south, for example. This magnet, what does it do? It attracts the armature. When the armature is attracted, what happens? These contacts literally touch. When they touch, they close the circuit and a current passes to the secondary circuit. Part C is made from a metal. Part C is made from a metal. Part C is made from a metal. Can you see this part C? Part C is made from a metal. What do you think this metal is and why?
Iron.
Iron.
Iron. Why?
Temporary magnet.
Switch it on and off.
Temporary
temporary magnet.
Okay, because it can be switched on and off. Okay, temporary magnet because it can be switched on and off. Yeah, last question. How many neutrons do we have and what's the charge on this particle?
110 minus 85 ثانية.
210 minus 85, which
Charge
is
neutral.
125.
125, which is neutral, correct? Yeah, 25 neutral, and then the other particle is
Proton 85.
proton, and we have 85 of them. Okay, astatine has half-life of 8 hours. The count rate is measured over 24 hours. Sketch a line to show how the count rate can change over these 24 hours. This is a new question, but definitely, sure, definitely, whenever we have a half-life, we have to draw a curve, a decreasing curve. Okay, If you check any question regarding the half-life, how will the graph be drawn? All of them. Okay, literally all of the half-life curves. How are they drawn? They're drawn this way. That's it. That's it. That's it. That's all that's all you have to do. You have to just draw a curve, a decreasing line. Okay. The thing is, I don't want to see a straight line. I don't want to see a positive curve. I don't want to see direct relation. I don't want to see any. What do I need to see? I need to see a decreasing curve moving out, starting from whatever point, okay, and just moving downwards. That's all I need to see. Okay. Okay. The mass of a sample is 0.5 kilograms. Calculate how long it takes for 0.375 kilograms of the sample to decay. I need to see how much time will it take for 0.375 kilograms of the sample to decay. What do I mean by decay? For 0.375 kilograms of the mass to leave, for example, or to be emitted. Initially, I had a mass of 0.500 kilograms. Am I left with 0.375 kilograms? No. I will not be left with 0.375 kilograms. I will be actually left with how much? Minus 0.375. I'll have to be left with 0.125 kilograms. That's the final amount. That's the final mass that I will be left with. Why? Because these 0.375 kilograms, they will be emitted. When I say for the sample to decay, they are emitted. Okay, they leave the mass, okay, they're radiated. خلاص, they're emitted. How much time does it take? How much time does it take? I need to calculate how many half-lives. How many half-lives? 0.500 divided by 2 is 0.250. And then divide by 2 again is 0.125. How many half-lives did I take? I took only 2 half-lives. I divided by 2 twice. I halved 2 times. Okay? So 0.125 is the final mass remaining, How much time did it take? It took 2 half-lives. Each half-life is worth how much time? Each half-life is 8 hours. Each half-life is 8 hours. So 2 times 8 is 16 hours. Okay? Okay.